Well, welcome everybody to the Tech Talk for whatever month this is, October. One of my favorite topics back in the day was internals. One of my favorite classes that I taught was the internal architecture. We're not going to dive as much into the heavy, deep internals as I wanted to for this presentation, but there's definitely internals. And one thing interesting about that class is that it was a tech support class first. Actually, there was tech support material, and we built a class around it and said, let's put it out there, see what the clients think. We didn't really expect it to take off, but it turned out to be one of the favorite classes for clients. And it made sense to me because a lot of you have been using the product a long time, are very deep in knowledge, and wanted to see under the covers, well, why is this that? And why did that work? And that type of thing. So, yeah, it was a blast. And it was one of those classes where I did say to them, you may not ever use this, but when you do, it's going to be handy. And I remember Dave Buchholz from TSYS back in the day texting me and saying that, that you said we'd never use it. I used it last week. Like he was very happy. So Dave's always a good informants advocate and been around a long time. I'm sure a lot of you remember him. So anyway, all right, it's being recorded. I don't care if you mute your line or not. I really would like for you guys to stay open and jump in when you need to. I hate presentations where I'm just doing the talking because I'm pretty shy, so I really don't want to do all the talking. But if you unmute your line, I'm fine with that. And or you can throw questions in the chat. I can see the chat, and I think Bruce and Rhonda and whoever are watching the chat as well. I pulled a lot of material over the years, so you're going to see a bunch of different formats and page numbers and all this other stuff. And it shouldn't matter because um, I could have went through and reformatted everything. Those of you that have tried to do that, tried to pull an old presentation into a new one, you know what happens. So I said I'm not going to play that game. It just would take way too long. There's a bunch of internally stuff and a bunch of foundational low-level concepts. I hope I don't lull you guys to sleep with page structures and things that you might already know. Even some of it's foundational for stuff I'm going to do later. So um, remember that if I say it depends, it really does. It's not one of those brush offs that, oh, I don't know the answer, so I'm going to say it depends. I won't do that. And there's a lot of really brilliant people on the call, and there's people on the call that know a lot more than I do. So um, if you guys ask a question and I can't answer it, I will not be offended if you jump in and answer it for me. I would not care. So. If I say I'll get back to it, I don't remind me. That's more of a classroom bullet, but still kind of true. But it's more of if I say I'll get back to it and a day goes by, make sure you remind me. Please ask questions. There's nothing more boring for me than a presentation where there's no interaction, no questions, that type of thing. I tend to talk much slower than I used to, but I tend to get wound up on things that are kind of fun. And so slow me down, ask the question again and again, say hold it, go back, whatever. It doesn't matter to me because there are quite a few slides that have a lot of detail, and I'm not going to brush over them. In my last presentation, I had so much material, I definitely know I went too fast. So this one, I'm going to slow down and cover what I can well, excuse me, as opposed to having goals for covering everything. Who am I? There I am. So there's all the stuff I've done and whatever. I'm not going to go through all that, but been doing informants work a long time. A lot of you guys out there on the call already have been doing it longer than I have. But yeah, it's been a fun career. I miss the teaching very badly, but I don't want to travel, and that's pretty much the end of that. And I don't want to do just online teaching, so that's why I'm doing what I'm doing, DBA type work right now. Quick dedication to Ron. Most of you remember Ron. Unfortunately, he passed away recently. The post said, or his obituary said, a fall at home. I didn't get any details from Dawn. But yeah, Ron was a lifelong advocate, wrote probably the de facto standard book over the years, the Informants Handbook, founded and owned One Point Solutions. And the thing I remember about Ron, he always wanted to go do stuff. After we had presented all day, he always wanted to go out and party and do whatever. And I never had the energy. But if you look at his post and Dawn's post on Facebook, they were constantly doing something, going somewhere. So yeah, it's sad to lose Ron. So we'll definitely miss him. All right, here's the topic list. There are some must-haves on the left that I'll be working through. Um, I grabbed a few of the VNext features that I could do quick proofs on. I don't have a vNext version, of course, but I kind of played with some of the things that are coming. And wow, now that I think about it, I'm on a 14 version, and based on what Art said, so you'll see what I mean when I get there. So um, I'll be diving through some of the refresher type stuff, some of the review type stuff, but I'll be digging through the must-have list, intermingling them with some quickies. You guys just lose my screen. Hold on. There we go.
Yep.
I got a message from my Mac that says to install software, do this as a thank you. I'll be diving through, intermingling some of the quickies. They're only one or two, three slides. There are actually some good ones, but one or two, three slides. And then if I have time, we'll do some nice to haves. I doubt very much we'll get to the nice to haves. And that's the compression topic that I'd like to do in an upcoming pitch. Use that presentation and add to it as well. So let's do this. Let's go ahead and dive. Again, the understanding is that there are people on the call that have never seen the low-level disk architecture. I know, looking at names, there's been a lot of people that have seen it. So bear with me as we do some refresher for some and some new stuff for others. One thing that I always wrestled with is I always call a database instance an engine. I've always called it an engine. But there's all kinds of names. Some people still call them an instance. Some people actually call it a database, which I think is funny because within our engines, there are many databases typically. But I'll call it an engine in most of my slides going on through the presentation. All right. Somebody once said, what would you call an IDS engine or instance? That says instance, of course, because I stole this from a red book, by the way. I've always said memory processes and disk, and that really is still true. So if somebody stops you in the elevator and says, what's an IDS engine? You say it's memory processes and disk. I'm not going to read through all this. This is going to be pretty quick until we get to some more detail. Looking at a big engine, looking at an engine, we've got three segments: resident virtual message. Message segment is optional. If you're not connecting via shared memory, you don't need a message segment. Most of my sites, I leave it up there for this and that reasons. There are certain tools that I believe, if I remember right, only connect through the message portion. But anyway, so many on-init processes, commonly known as VP or virtual processes. These are processes that are at the Unix level, or whatever OS level you are at. They're full-blown processes. They're managed by the operating system as far as the process context, but as far as the threading within the processes, the engine manages that. And that's one thing that just makes the engine so powerful, is we take care of the context switching by making it lightweight context switching versus heavyweight, meaning for every connection, we don't have a process. We switch the threads. We don't spawn processes. And that's old news by now. That's really the true definition of multi-threaded that actually came back from when? 1995, 94, something like that. We were so far ahead of the game. For DB space, you've got X number of reserve pages, 12 to begin with, more later. It used to be that all your reserve pages, when we extended the reserve pages, had to be allocated out of chunk one. That's no longer true. That turned out to be a problem with big growing engines for a while, because if you wanted to add another DB space and we could not extend the reserve pages past chunk one because it was just too small, then you didn't add the DB space, but that's no longer the case. Each one of your DB spaces will have a table space. Database table space, if there are databases in there. There's sysmaster, there's sysutils. The other one is onpload, the onpload database for HPL. Not sysutils, but what's the other one? Sysuser or sysusers. And that's about all I can think about as far as the databases that might fall in root. Sysadmin will fall there initially, and I always move it out to its own DB space. Sysadmin is what John put together back in the day for sysadmin API calls and a number of things to let you hold data persistently from sysmaster. And you have to enable a task to copy it over, et cetera, et cetera. So I have a lot of fun with the sysadmin stuff. And that, Bruce, that could be a potential topic as well. And I can't believe I'm volunteering for more topics. That's just ridiculous. But anyway, And you'll start with three logical logs and one physical log. You'll typically move those out, et cetera, et cetera. Okay, that's that.
Mark, can I ask a question here?
Yeah, go ahead.
Uh, Sorry if these are like very dumb questions because I just started working on Informix
No,
and
no, it's okay. It's okay.
I can see all those on init processes differently,
Hmm.
and I can see those DB spaces differently. But in memory, there are like, as you mentioned, there are three or more or maybe less segments. So can we see those segments differently, or it would be like, okay, it is there and we cannot have them and see them differently?
What do you mean differently? I'm not sure what you mean.
So suppose on init, I can see like, okay, there are 10 on init processes running. On
Yep.
DB space, I can just go there. There are different
Uh,
types of DB spaces. So in the
mhm,
memory area, so it would be consuming like, okay, from one, I'm just taking an example, from 1 gig memory, it is just taking like 500 meg just for like engine, or
mhm,
I can see that from that 100 itself that
mhm.
50 engine is using. So from that 20 is using resident and 20 is using virtual and 10
Mhm.
is using as messages. So is there any differential things in there? Okay. So somebody just mentioned G. Okay.
Yeah,
Segment.
the GGLO, the GSEG is the one. OnStat minus GSEG is a way to look at it from the engine. If you want to look at it from the OS level, IPCS minus M or minus MOP, IPCS will do it as well. IPCS in the Unix world will show you memory segments and semaphores. IPCS minus M will show you just the message portions on most Unix flavors. I like the MOP because it shows you the message portions, who created it, and other attached processes. So when you get a chance, what's your platform, Jagdeep?
Uh, it is 14. Right now it is 12, but we are moving to 14.
What's your operating system?
It is Linux.
Okay, yeah, on Linux, IPCS will tell you a lot of things. Okay. And I apologize. I wanted to add one more section to answer your question specifically, and I didn't get around to doing it. Looking at shared memory keys and that type of thing. As you dive in, please just send me an email. It's mark@markscranton.com, and I'd be happy to sit down and sit on a session and show you how to look at the shared memory segments, both with the GSEG. OnStat minus GMEM is also another one that I haven't spent a lot of time with, but it's there, and there's a lot of good documentation on it. But IPCS shows you a lot of good things, and like I said, the IPCS minus MOP, which I don't know will work in Linux or not, um, will show you the processes, the on init process by PID, etc. So um, the other thing Art was showing is the GGLO. If you ever want to look at the VPs, all right, so we'll do this. If we go back up here, let's talk about memory, the ways to look at memory. OnStat GSEG is one way to look at memory. OnStat or IPCS minus M is another way to look at memory. If we go to the process level, the most common one is what Art had said, OnStat minus GGLO. Believe it or not, that stands for global, which stands for multi-threaded. Believe it or not, that's kind of a funny story. But the OnStat minus GGLO will show you all the on and init processes and the types that go with. Plus, you can do a PS minus EF grepping for on and init. Now, if you have a lot of engines out there, you will see a bunch of different on and inits, or a bunch of on and inits if you haven't labeled them, and that's another tangent. If you haven't labeled them, it's difficult just from a PS to see which on and inits go where. And that's a script I've always wanted to write, is just one to tie all that together. But if you're looking at a single engine, for example, or any engine, the GGLO is really handy. Um, I hate to admit it, but I use the GGLO sometimes to go get CPU VP number one. Does anybody know what I do with it? Does anybody know why I'm acting really hesitant? What do I do when I find CPU VP number one's PID? What do I do? Thank you, Art. and Hart, I can't say your name. It starts with an H, but anyway. Yeah, exactly. If I can't get the engine to come down or I want it to come down really quick, an old trick, which is not recommended, but Art recommended it, so now it's on him. Um, do a kill -9 on that VP, on that pit, I'm sorry, and it'll bring the engine down. Now, one thing that I'm glad Paul mentioned, this is cool. I'm not going to have to do anything. I'll just let you guys chat and I'll just fill in. One of the slides I started working on, believe it or not, Paul and Art, and this sounds really convenient, is a slide with on clean. Back in the day when an engine would die, so let's go back. If I would kill CPU VP number 1 by PID, or the engine would just crash, we would leave shared memory segments out there. We might leave some on inits. The disk stuff at this point we don't really care about, and I say that lightly because anyway. So if you went ahead and tried to restart the engine, historically we couldn't restart because we can't reclaim those shared memory segments that got left behind. They're orphans in one sense. They're orphans to the engine, that is. Because when we go and allocate shared memory, we do a shem get me an ID, and then we do a shem attach. That ID is based on, here we go, server num. And we're going to try to reattach to that we're going to try to reallocate that segment or take that segment and attach to it. One way around that is what? Anybody? If I can't bring it up because the shared memory segments are still there, what's the way around it? This is too much fun. I love these open-ended questions. What do I change in the onConfig to be able to bring the engine up? Anyone? Server num, that's right. Art, you can't answer everything, but that's okay. We'll let Paul answer one, even though he spelled it wrong. Anyway, yeah, so you change server num, you're going to come up, but you'll end up with an engine that has new segments, and all the leftover stuff from the previous engine isn't there. Why did I say isn't there? All the leftover from the previous stuff is still there. Back in the day, we had to find the on inits. We'd kill the on inits. We'd have to get root if we didn't have it to drop the shared memory segments in most cases, and then go around and try to get the engine to come up. Somebody came up with a great idea to build a utility called, yeah, thanks, Art. Build a utility called onClean. OnClean minus KY is definitely one of the fastest ways. No, it's really the fastest way to bring your engine down. Keep in mind, if you do some digging, you'll find documents that say if the engine crashed, do an on mode minus KY. That's great. That's awesome. The minus K is actually the K intake offline. And most of the time, on mode minus KY will work. We'll clean up the shared memory segments, the on init processes, etc. I've known clients that by habit do it twice when they bring the engine down, or do it twice when the engine crashes. Well, if that always worked, we wouldn't have had to build the onClean. So I think onClean is a great little utility. I use it quite often. Yeah, but be careful because it will bring stuff down. There's no reminder of saying, do you really want to do this? Especially if you use an onClean minus KY. If you use an onClean minus K, it'll ask you. But you know where I'm going with this. So Paul said you can reboot the box. Yeah. I'm at a client right now that still wants to reboot the box every month. And they say, do you think that's necessary? And I said, I know clients that have been up for years without a reboot. And no, back in the day when they first started using the product, they were on early 7. So that's when they got into this cycle of rebooting the box, not the engine, but the box. So yeah, reboot will clean everything up, but with onClean, you shouldn't have to get into that too much. But man, you guys are giving me ideas of things I want to cover. Okay, and then the bottom section there is the disk. Well, I never thought this slide would take this long. The bottom section was the disk. OnStat minus D is your favorite. I use OnStat minus big D quite a bit, where it's showing read-write activity. And I'll show you a slide. The watch restore section will show you how I use the OnStat minus big D to benefit. What else? OnStat minus D, big D, GIOF, minus GIOF. Anybody can think of any other disk-related OnStats that I'm probably forgetting? If you think of one, throw it in the slide. IOH, what's that do, Art?
That's hour history for an hour, for the previous hour.
I'm sorry, does what?
IO history, chunk by chunk, for the previous 60 minutes.
Oh, okay. Awesome. I haven't used it too much. IOQ, Paul?
You'll use the IOQs, particularly the max length.
Okay, max Q lengths. what do I use? How do I see that now? I wonder. I'm always surprised when I don't know off the top of my head something, but anyway. Well, that sounded really self-serving, but anyway. All right. This one I have to show just because of this stuff right here. This slide was created way back in the day. It's way before I had grandkids. I've got 13 grandkids now, or no, I've got 10 grandkids now. A friend of mine has 13. These are my kids, Josh, Jared, Jacob, and Jordan. This is my ex-wife's daughter, and this is my kids' database. So anyway, just a couple of engines. I'm not going to spend time on this. I just wanted to show off an old slide from back in the day. Look at the date here. That's not when I wrote it. That was written. This slide was created a long time before February 2014, but oh well. All right, let me see what else we have. Just a little bit of a bigger picture of the resident segment. Yeah, and this could generate some conversation. We added configurable buffer cache, configurable page sizes back in what, 9.4 or 10? I think it's 9.4. Man, I'm getting old. 2K, 8K, 16K. In one of the environments I work in all the time now, we've got a 4K page cache because 4K is the standard. It's AIX. And then I've got a 16-page buffer cache for indexes and stuff like that. We will be talking about the limitations on data pages with respect to 16K pages coming up, so hold tight. Lock structure, a few others, logical buffers, physical buffers, a little more on logical buffers coming up, and logging and physical buffers as well. Slow me down when I go too fast. I know we've got a lot of stuff I'd like to get into, so what am I talking about here? Okay, fine. All right, let's just get moving. Virtual segment, session pools, sort pools, PDQ memory, light scan buffers, light append buffers. If you guys haven't paid much attention to light scans and light appends, they're very important. OnStat-G LSC and OnStat-G LAP. If you're using HPL or the P-loader or things like that for bulk loading, heavy loading, unloading, whatever it might be, external tables, whatever it might be, light appends and light scans are very, very important. In a word, light scans and light appends bypass the buffer cache. So you don't run into issues of the buffer cache being flushed, pages being used, buffer cache being too small, etc. So if you haven't dug into LAP or LSC, I found it to be very handy. All right, so additional segments, and then the message segment, we know what it does. That's about it. Oh, real quick, for those of you that are newer to Informix, don't fall into, slow down. Don't fall into this trap. I had a client a few years ago that called and said, it seems like about 50 people get logged in and then the next person can't get logged in. I said, okay. And I assumed at that point they were probably not using shared memory because they were a mature client, and actually that wasn't true. I said, I think I know what it is. I said, and I look out on their box, and sure enough, they were using shared memory. The clients were logging into the engine from the same box. There was no net type parameter at all set because the default size for shared memory connections, default number of shared memory connections allowed is 50 if you don't set it any different. So if you are using shared memory only, which less people are now, I hope, then and you don't have a net type, you're going to be limited to 50 users concurrent. So keep that in mind if you're relatively new to the product. Okay, I like this little slide. It just kind of summarizes things. Everything starts with a page. It says 2 to 16K. We had talked about having a 32K page, and I don't think it's there yet. If anybody knows it's there, please correct me. A chunk, contiguous pages from disk, permissions, ownership, and group. Somebody creates a table, whatever, they get an extent that comes from that chunk, a group of pages, contiguous, notice that. That initial extent for the table, you can say that's the table, but it technically is what we call a table space. If you're newer to the product, we use table space a lot. With respect to, say, a partition or a table, we even have table spaces that have indexes. Now, I know that's going to be confusing, and I've got a slide coming up later that is a little more clear, so just bear with me. Oh, that was it? Okay, yeah, that was it. Sorry. Thought there was more to it. There's another one that has more to it. All right. Any questions? Let me check off what I just did. All right. Questions, comments? All right. Oh yeah, Art says all Informix concepts have multiple names and uses. It said I agree with that completely. And then I do have a slide coming up that shows the ridiculousness about that. Actually, I think it's in the next section. Let me see if that's it. Okay. They're actually not going to grow this in vNext. I think 32,767 DB spaces is probably enough. Where's that slide I'm looking for? DB spaces added, modified, I'll drop it on the fly, blah. A DB space can't be dropped if it's empty. There's going to be something in vNext that helps the problem of dropping a DB space, or a chunk, I should say, if the table space has some stuff and it's not being used, etc. In vNext, I think it is too that mirroring is going to be enabled by default. Most people, I think, don't worry about mirroring because they're doing mirroring at the hardware level. But the fact that we made it on by default and the mirror parameter is going away makes me wonder if more people are using it than I think. So, and it could be there now. Paul says he thinks it's there now. It may be in 14. Most of my work in the field right now is on version 12. I spun up a version of 14 for a number of these slides. It's not this one, obviously. A number of these slides. So some of the stuff I've got with 14, but yeah, definitely jump in when you know it's there or not. So FC5 has mirror on by default. Good to know. Yeah, so guys, do we think they did that because more and more people are using mirroring, or yeah, I knew that, Art, we can swap primary and mirror chunks, but do we think we made that?
That's why they turn it on by default. So
Yeah, the main thing is you move things around on the file system without having to take any outages. Combination of a mirroring and the swap mirror chunk.
Okay. I read the swap feature and I was trying to think it through, and I read exactly what you said, Paul. I just need to play with that. That sounds like a pretty cool little thing. So.
Move data from one structure to another.
All righty. Art, you're coming across real fuzzy, by the way. So we kind of get the tail end of what you say, but not the early stuff. So don't know if it's a microphone issue or headphone issue, but we're kind of missing it. So. All right. I'm just flying through, seeing where I want to stop. This is the one I was talking about. So for those of you newer to IDS, I still call it IDS. I'll always call it IDS. This is a good slide to think about and to maybe capture a picture with your phone. There, you've got table space, table, fragment, partition. They all point to, and that arrow should come down to here. It's not pointing at the DB space. I apologize. That arrow should be in the front, not in the back of this right here. So if you look at this little guy right here, a non-fragmented table called Skippy, we can call it that. And as far as the numbers go, there's going to be a table space num and a part num. In the case of Sparky, there's going to be a fragment ID, which is actually the same format as the partition number. It's the fragment ID and the part num that let you point to different fragments without having the issue of duplicate row IDs. That's a whole nother topic. Paul says the primary mirror swapping got him out of a major Red Hat issue with zero downtime. Excellent. Yeah. All right. So that's a good slide for those of you that have not been around for a while. Okay, a few more. And again, I'm trying to, these slides are actually generating some good conversation, so I'm pretty happy. I thought they would be pretty quick to fly through. I'm not sure what I was trying to point out here. Just showing a typical common common engine with the DB spaces. Yep, we'll fly by some of these. Oh, I used to get this question back in the day. Can everything be put in one DB space? Yeah, sure. Best practice, don't. Shouldn't be. Some advantages of multiple. Monitoring has always been a great thing. The more you know about the OnStat utility and its different options, it's hard to monitor which table is hot if you have a single DB space, etc. Operations granularity, many ops at the lowest level is the DB space level. In a general rule, you get one scan thread per DB space, with the exception of index builds and archiving. No, that's not it. Index builds. What's the other one? What's the second one? I used to travel around and know this off the top of my head. A couple of operations where you get multiple threads for a given, if you have multiple chunks in a DB space, but in most cases, it's a single thread per DB space. So again, one of my favorite stories back in the day was a client had put all of their stuff in a single blob space. And I said, you guys are going to run into problems. Well, in 2017, they did. Everything came to a grinding stop. Went out there, and we had suggested, me and another consultant had suggested, that you go wide, not tall. You need to be wide so you have multiple DB spaces, so you have less contention, parallelism, whatever it might be. And when I say parallelism, you don't always, you've got 5 DB spaces. It's not that you always want to do stuff in parallel 5 ways, but the thing about PDQ and fragmentation, think about your 2 goals are really fragment elimination, or parallelism first, and or fragment elimination. Worst case, best case, you get parallelism. You can read those 5 segments in parallel. Better case, if it's applicable and if the conditions are right, you can get fragment elimination, where I've got huge DB spaces and I eliminate 4 of the 5 and just read 1. Now you're going to read it in a single thread in most cases, but still, you've eliminated 4/5 of that data, and that is typically a good thing. Archives and restores, same thing. One thing I'll show you coming up is my little utility to watch the restores, and I'm measuring pages in hundreds of millions. I'm measuring in millions of pages per hour, and one of my engines doesn't have a lot of width in the DB spaces because it's much smaller, where the other engine has a lot of width across a lot of different DB spaces. So the millions of pages per hour is much higher. We actually have one DB space that is very tall and very deep, and it is the last one to go. It gets tried first, but it gets put on the back end and comes around at the very end of the archive, and it takes absolutely forever. And so it stretches the archive out by a good 30 minutes. And I know that doesn't sound like forever, but it could be done in 5 minutes or 10 minutes if it would be parallelized. How's that? Parallelized, not paralyzed, but parallelized. Anyway, reduction of extent you're leaving. That's if you got multiple DB spaces spread out, etc. The odds of having extent interleaving is going to be less. But we've improved the way we handle extents a lot over the years. So anyway, all right, let's see. I don't know that I want to do a lot of this. Some of these numbers are old. Let's fly by some of these. I apologize. I just want to get through. Okay. Let's see. Let me think. Yeah, I want to do this real quick. If you're relatively new, we had the ability to add configurable page sizes in 9.4. It was a big deal, huge deal. It used to be that your page sizes were only what the default is for your OS, 2K and 4K. Yeah, 2K and 4K. You can define these at the DB space or buffer pool level. Last I heard, we can go to 16K. New configuration parameter called buffer pool. It falls at the very end of your own config. It gives you all kinds of options, including an extendable option now, which I haven't had a chance to play with too much yet. Configurable page size requires large chunk file support. It was also introduced in 9.4. Just a quick slide to show you the overview and a couple of remembering things. Oh, sorry, it's not the one. Sorry, I'm going too fast. One thing you have to deal with right now is you're going to end up with 1 buffer cache per page size. 2K or whatever your default is, 2K, 4K. Your root DB space is going to have that page size. You might have some other DB spaces that are part of that buffer cache, but that's what's being tangled up in the default buffer cache size. 16K buffer cache, 16K page buffer cache. A lot of people will build indexes in there, 16K pages, or their index DB spaces will be 16K pages. Remember, there's a limitation on how many data rows you can put on a page, regardless of size. With indexes, the limitation is however many you can squeeze on there. Now, excuse me, with indexes, there's a lot more overhead per index row, depending on a number of things, than would be for a data row, assuming it's not split across multiple pages and such. But if you can squeeze a lot of index rows onto an index page, good for you, and that's one reason we do it. Excuse me. I'm gonna have to start smoking if I'm gonna cough like this. All right. This is one of my favorite little parts, and I'll dive in a little bit. We've been kind of high level so far. So let's talk about configurable page sizes, what to consider. 1, 2, and 3, space efficiency, increased maximum key size, Unicode support, and access efficiency. But first, some review on page and row overhead. Now we're diving a little bit. This is the part that I don't believe has changed at all, since some of the innards of the page header has changed, and the use of the page trailing timestamp. It used to be that there was a timestamp in the header and the page trailing timestamp, and one of the ways we figured out if that page was good is those values had to match. Not anymore. We changed it. We stole some of the page header timestamp for the larger page address back in 9.4. But as far as I know, there's still 24 bytes in the page header and 4 bytes in the page trailing timestamp. So if you do the math on a 2K page, 2048 minus 28 is 2020. My most favorite joke is 2020. Is that clear? And that's why I miss a classroom, because I can see you guys falling off your chairs when I made that joke. So I appreciate it. Thank you. But that's the typical page. Now, this is a typical page, whether it be data page, index page, or otherwise. Blob pages will definitely look different if they're blob pages that are stored in the table. That's been so long since I've dug into blobs. Blobs have the potential of looking significantly different. So I apologize, I don't remember all the detail. But this is typical. So when you go and calculate how much disk you need, you know the rule, calculate what you need and double it. If you want to be a little more specific, you got to remember that for every page, whether it's 2K, 4K, or 16K, this is the initial page overhead regardless. This slide I really like. It was difficult to put together, but it really tells the tale. Where you've got your 24 byte page header, your 4 byte trailing timestamp. This down here, hopefully you guys can see my arrow. You guys can see that, right? Can somebody give me a thumbs up? You can see the red arrow?
Yep, we can.
Okay, thanks.
Yep.
At least I can. Yep.
Yeah, this is technically the slot table down here. This is technically slot 0, but it's the page trailing timestamp. Slot 1, slot 2, slot 3, slot 4, or whatever it might be. In this case, a slot equals a row. So slot 1 is a 4 byte entry that shows 2 bytes for the offset and 2 bytes for the size. It literally points to row 1. In this case, it's right past the page header. So the offset in that case would actually be 24 because it's 0 through 23 for the page header. Byte 24 would be where the offset or the row starts. And then it has the size of whatever size it is. Same with slot 2. Slot 2, and that arrow got chopped a little bit. Slot 2 points to row 2, etc., etc. So the slot table works its way back to the rows, and the rows works its way forward to the slots. Is it possible to use every byte on that page? Of course. Is it unlikely? Probably, because you're going to end up with some leftover. As soon as you can't put a full row, a full-size row on that page, we have a choice of either splitting it and leaving back a forward pointer, which I'll talk about in a minute, or and have that forward pointer point to the slot table on the other page, etc., or move that entire row off to a different page. We tend to lean towards moving that entire row off to a different page. We'd rather have a full row on a page than a row split. That's a problem with small pages as well. If you have really, really long rows, one of the things we're going to get into in a minute is if I've got a data page, strike that. If I've got a data row, there's 3,000 bytes. Let me pick something bigger, 25,000 bytes, and I've got a 4K page. I'm not going to be able to store that entire row on a page, of course. I'm got to split it across multiple pages. In a few slides, I'll show you how that's done and the additional overhead that goes with that. You still are limited. All right, let me switch. On the other hand, if you've got a 5-byte row, and this is something you want to remember for a later slide. If you've got a 5-byte row, you're thinking, I could put a lot of 5-byte rows on a 16K page. You can't if it's a data page, because there's still a limit of 255 to the number of rows you can put on a data page. The limitation is because of the row ID format, which I'll talk about here in a minute. Okay. I can't believe I'm tangenting like I used to all the time. This is so much fun. So that's that. The data row, the minimum overhead is 4 bytes, which is this, or this. Now, on the index row, you're going to have the key value, the row ID, which points to the data page, potentially a fragment ID if it's a fragmented table, and then you're going to have a 1-byte delete flag. Way back in version 5, we used to not have a delete flag, and we used to have adjacent key locking problems of all kinds of sorts. In version 7, probably in version 6, but I never touched version 6. Nobody else would want to either, I heard. The 1-byte delete flag was put in, so when a row in an index row gets deleted, we flip that from 0 to 1, and then initially the B-tree cleaner, the single B-tree cleaner thread, would come through and clean up the B-trees, maintain them, do whatever it might do. Then we move to B-tree scanners, where we can have multiple scanners because the B-trees just got too big, and a single B-tree cleaner thread couldn't keep up. Thing that's interesting is that I think the parameter in the onConfig is still says cleaner, even though we refer to it as scanners because you can have multiple scanners. So, and I hope I don't have that backwards, but anyway. So here's the index row overhead, something to think about. Data indexes, where it might be. Look at the overhead. Row ID, fragment ID, 4 and 4, delete flag, slot table entry, 13 bytes. The index page is going to have a slot table entry as well. Okay. Row ID, fragment ID, if it is not fragmented, okay, then you're going to have 9 bytes overhead. So when you go in through your calculations, and everybody's put a spreadsheet together to calculate how much disk they need. As disk has gotten cheaper, I think we've gotten sloppier, where we say just throw X number of gig at it, but you still need to know. You still need to be able to do the calculations. Like I said, all of us have spreadsheets or applications or something that calculate projected data size or disk size needed. All right. Space efficiency, a quick example. A row size of 1,200 bytes, 1 row on a 2K, 3 rows on a 4K page, you save 33%. For 30 12-byte rows, 2K requires 60, 4K with only 40K, 6K just 36K, a 40% savings. So that's one of the biggest reasons we wanted to go into configurable page size, or offer configurable page sizes. Let's do a quick page dump. OnCheck PP. This is going to say, give me the partition number or the table space number and which page do you want, okay? I've got some OnCheck examples coming up that you'll like, so we'll get more into the detail of that. This happens to be a data page. It's at this address. We don't care about the address because there are 2 versions of OnCheck. One where you push the address and the page offset, and one where you push the table space number or the partition number and the logical page. I may have said page offset earlier, but the logical page. Logical page 1 in this table is a data page. There are 28 rows by 134 bytes, okay? Okay, let me slow down. The length of this row is 134. Forget about this. This is one, that's right past the header, next, next, next. Flags we don't care about because it's a data page. Actually, those flags do have a purpose. I can't remember what they are, but anyway. 28 rows by 134, 28 rows by 4, which are the slot table entries. The page overhead is 28. We think there should be 3892 used bytes. We think there should be 492 free. And trust me, I did this math before I did this, and it is matching up. There's the free count. That free pointer is where the next available space is. Previous and next are used primarily for B trees. I think there's something we steal them away for, but I can't remember. And that's that. Okay. So on check is handy. It can be really confusing, but if you want to dump pages, that's the way to do it. You can dump them with DD as well, but on check has 2 flavors and it comes in very handy. Okay, here's a quick proof. The 2K port, max row size of 208. Those of you that went to the master series, you remember the 10K TUP 1 table? It's been a long time, I know. 208 byte row. 16, let me go back real quick. Look at the number of pages allocated, 1120. Pages used, data pages, whatever it might be, 1112. Whereas if we go to a 16K page, this is a different table name, but the same length. Notice the number of pages used, 2K, 1112, 16K, 130. Simply less pages. Don't only think of this as a savings on disk. Think of it as a savings also in, for example, the buffer cache. Okay, the buffer cache is also going to benefit by having less pages. Okay, I'm going to skip over Unicode support just to get to this slide. All right. Unique index. This is on check minus P big T. Not little t, but on check minus P big T against the Wisconsin database, this table. Notice the difference between the 16 and the 2K. Ready? Real quick, forward pointers. If you ever wondered how this happens, and the key point here is when you have very long rows, you're going to end up splitting the rows across multiple pages. If you do that, you're going to inherit more IOs because you're reading multiple pages. Now, you're probably reading them in blocks or big blocks. That's okay. But you still have multiple pages. When I pull those multiple pages from disk into the cache, they have to find a home page by page by page. So the more pages you have, the more potential for difficulty. Not to mention, you end up with forward pointers. So follow me here. Give me the data stored at 1B01. This is page 1B. This is slot 1. It points to there. It happens to find a forward pointer. So it knows this is the first part of the row. This forward pointer says go to page 1C, slot 01. It goes to the other page. It finds the row offset and the row size and goes here. That's clearly more than 8 bytes, so pay no attention to that small anomaly. But the point is, these are 2 separate pages. For a single row, who cares? For 100 million rows, you care a lot. The client I spend most of my time at, our largest table is 2.6 billion rows. I did say billion. That's a single table. Yeah, I've been arguing with him since I've been there about doing something about purging off some old data, but that's a whole nother story. So I begged and pleaded for that, but it just hasn't happened yet. All right. There's another example of the forward pointer, home page, remainder page, remainder page, remainder page. Okay. Again, as you're reading through rows, if you have hundreds of thousands of rows, if not millions of rows, you're tying up those chunks as well, or maybe even tying up that DB space if you have a single scan thread. So again, multiple benefits from configurable page sizes. Buffer pools, we talked about this a little bit. Okay, this is the parameter that allows you to change the page size. This slide is a little confusing. Let me show you what it means. Everybody said, well, this is 2K, this is 16K. What's this one? That's what's used if we end up having to create a buffer pool on the fly. What that means is if I go ahead and do it on spaces and add a 16K DB space, I'm sorry, just add a DB space. Forget about 16K. I add a DB space on the fly, don't designate a different page size. Then it's going to use the default right here. Otherwise, it's best to create these buffer caches like this in the onConfig, bring the engine up, let them be there with their right page sizes, and then add the DB space after the fact. But yeah, you can add the DB space on the fly. It'll use default. Better to put it in the onConfig, bounce if you can. You can't always bounce, of course, just off the cuff. But if you got those two methods to choose from. All right, let's get into the issue with the row ID. The primary purpose for CPS is to accommodate larger rows. Be careful. The rows per data page limit is 255. See when this slide was written? Still enforced with 10. That's when we introduced configurable page size. I think it was 9.4, but anyway. Regardless, the max rows on a data page is 255. This is simply due to the row ID format. It's not, and I say it's not, a limitation of the page size. And again, that would not make sense if you had a 5-byte row and we can only stick 255 rows on a page. Do you end up wasting space on a page? You do. If I've got a 16K page, 5-byte row, I know I'm repeating myself, you'll waste a lot of that page if it's a data page. The reason is the row ID is a combination of logical page number within the partition or within the table space. Those all mean the same thing. And the slot or the row number on the page. We went through that just a few slides ago. This is a 1-byte number. How big can a 1-byte number be? 255. That's it. Okay. That's why if we allowed you to put a 256th row on a data page, how would we point to it? We wouldn't be able to find it. So we can only address 255 rows because of this 1-byte limitation in row ID. vNext, which I think they're calling 15, but I don't know for sure, rumors to be modifying the row ID, I assume making it bigger, to get past this and probably some other reasons as well. But if you move to version 15, make sure you still check that your limitation is there or not. And if we change the row ID format past the 4-byte total, I'm sure it's going to be well talked about and in the release notes for sure. So, any questions on that? Again, I'm going really fast, so just raise your hand, jump in if you have questions. Okay, I think we've probably beat this to death. Let me go back. Okay. I think we just did disk overhead. Yeah. Let's, I think we did configurable page sizes as well. Yep. Let's do this. Let me throw a quickie in just for fun. Let's see. Let's do this one. Okay, change of topic. I just want to throw this in. It's got about 3 or 4 slides. That's it. This is a script I put together to watch restores. We've all had to do restores. When I first arrived at the site I've been at for a while, we just never knew how long it was going to take. Initially, it would take about 8 hours. Okay, and now it takes about an hour to do the restores of the engines. That's all. But I wanted to write a script that would help me look at the rate, the number of on-bar processes to make sure that it's in parallel to a degree that I like, what DB spaces are being written to, any errors from bar act, any errors from the online message log. I've used it to troubleshoot storage manager issues. When I see the rate is really, really slow, then I might call the storage guys and say, is something going on with TSM, or now we're on network or DD. The good news is we got a new switch in our production environment, and all of a sudden I see the page rates going from 100 million to 900 million an hour. And I literally called my friend Jay and said, what happened? He said, oh, we gave you a new switch. I said, it's working. So if I don't have a lot of parallelism, it means that I probably need to change the bar max restore, okay, threads, to allocate more threads. Be careful, because bar max restore, for example, and bar max backup, documentation will tell you that either one of those you should be able to set to 0. and on bar will figure out how many threads that the storage manager could handle. We tried that. We blew up a box doing that. There were thousands of threads that were ticked off, which makes no sense whatsoever because it should be a function of the storage manager's back-end disk, the tapes, the whatever they're using. Most of the time disk now, but that's not always the case. So be careful with bar max backup and bar max restore, setting it to 0. If you even have any inkling to do that, put it in a test environment. Fortunately, that's where what I blew up is my sandbox, which is okay. But I don't think I would ever throw that in production without a lot of testing, or if at all. So here's what the script looks like. Well, it's one of my favorite effects. Anyway, as you can see, it tells what time. Whoops, sorry, I clicked. Didn't mean to click. There we go. It tells what time it started and then gives me the messages out of the bar act log. This is just, it says the last 3. Of course, I've changed that since then. It gives me the last messages out of the bar act. I think I'm doing a tail minus whatever that is, a tail minus 10, for example. This script goes out and finds the bar act log for this engine, which happens to be the standard default name. It could be something else. It doesn't matter. But that way I can see what's going on. I've got the bar act messages, the bar progress configuration parameter set to 5 minutes or 300 seconds. So I always get something every 5 minutes. In this case, it's an engine with a lot of DB spaces. We've got a couple thousand probably. And so the last 10 messages, I'm not going to see the change in time because it's just the last 10 messages from all those threads running in parallel. If there were any errors, it would show me that here. There were no errors in this screenshot. Actually, I think I just truncated the screenshot to make it smaller. The next section is really handy, I think. This is where I'm using onstat minus D, big D, not little d, onstat minus big D. It's telling me what's being written to, and this is pages written and pages read, I think. I may have that backwards, okay? It's written and read or vice versa. We're probably, let's see, we're restoring, so we're probably writing. So it's read and written, I would guess. This is just a partial output of all the DB spaces being written to. It will show me a couple things like if I see one DB space with a high number, and that's the only one on this list in this case, this output is a function of this column being something other than 0, of course. Or actually, I probably do both. This column and this column, because it's read and write, being other than 0. So this gives me just an idea on what I have got going on activity-wise. The way I calculate this is I actually use an onstat minus z, little z. Those of you probably remember that zeros, the technical term is it zeros your profilers. For most of us, you say it zeros your statistics. Now, when you say it's a statistics to me, I think of update statistics. No, the profilers fall in sysmaster syshemvals. Let me put that in the chat. I should probably do this. Thank you, Doug. Yeah, Doug put in the chat that this is page read here. This is page write. Yeah. Does that work with on tape? I don't think so. No. Oh no, definitely not. Because on, I don't know. That's an interesting thing. On tape doesn't give you much output. Ashok, let me tangent here a little bit. The question is, does it work with on tape minus R? On tape doesn't give you a lot of progress information, but you probably could watch. But the engine's not up. I don't know. That's interesting. So does anybody know if Barry have you used on stat minus D against with an on tape job running? Huh, it's interesting.
All the time. It shows you which DB space it's currently, which ones are done, which one it's currently restoring, and you can see the read and write. Well, the write activity. Isn't
so it's essentially showing what I have on the screen now.
Yep.
Yeah, okay. What you wouldn't have is the information from the bar act log because you have no bar act log. You could actually, correct. Yeah, you could do some other things. I haven't touched on tape in forever because the sites I've been at are big enough to use on bar. And Doug says, for those of you on Linux, Linux Watch, which I have not used, Doug, do you want to tell us what that does?
I'll unmute for the first time. Yeah, it's a general purpose Linux command that you can get it to watch the output of a command.
Okay.
So you can get it to successively run the on stat minus capital D, let's say every 10 seconds, and there's flags to show to highlight differences. So
Oh.
you do that, it's going to clear each time, and it will show you in reverse video the portion that's changed since it last displayed it.
Are you kidding? That is wow. Because we've all done a while true, right? We while true, we put our commands in, we sleep it, we clear the screen, whatever. But it doesn't highlight what's changed. That's incredible. I don't think there's anything like that on AIX, but that's I'm gonna have to remember that one. That's wow.
You could
You
probably
guys-
get watch from the Linux tools for AIX, couldn't you?
yeah. Sure. I think so. Wow. Because I understand
I
that
want to
stuff.
try that watch command now because on AIX it used to be run the onstat-d into an output file and then wait 10 seconds, run it again into a different and just do a diff between them.
Oh
And
yeah.
that shows you all your differences, but the watch seems cool.
Yeah, but the diff, the diff just points left or right. I found diff is okay. I use it a lot, but it's not as cool as what Doug is talking about for sure. So yeah, that's cool. That's good to know. Let's go back. Okay, what was I talking about? Oh, onstat minus little z is what I do in this script. Now, I do this in this script because I'm doing a restore. I don't care that I'm zeroing the profilers. And again, the profilers are in sysmaster sysgem vals if you want to go see where they are. Sorry, I've got schools letting out down the road and my door's open, so hopefully it's not too noisy. But that's how I end up getting the new numbers all the time. And as you see, let me go forward a slide. Okay, let me do this one. Then the next slide is the one I wanted to talk about. Here's the rate slide. Pages per minute, pages per hour in millions, 273. 273 pages per hour, blah, blah, blah. I've got bar max backup set to 20. And this is probably a grep gone wild. I probably forgot to grep minus, get rid of my grep. But anyway, it says I've got 22 on bar processes. It could be the on bar D and then the other on bars plus my grep would be 22, I suppose. This is when it started up. This is when it took off, and this is when it grew. We were using, back when we were using TSM, which I'm very glad to be rid of, we were getting 900 million on this same engine. Now you're thinking I'm only getting 273. Networker to data domain is significantly faster than TSM was, even at 900 million. So not too unhappy about that. But this is a nice output. One thing I'm surprised I haven't done is haven't captured this to a thing called a table. I probably could learn all kinds of things if I put this in a table and looked at it historically, but I'm just too lazy. But that's really handy because, again, it helps me understand what the rate is and how long it might take. But again, now, because it's so fast, I mostly look and see if on this engine I've got 15 million, 17 million, 20 million, whatever, constantly. And I know that I've got 22 on bars running, then I know there's definitely something wrong on the back end. Another engine I do, which is much smaller and has a lot less DB spaces, definitely gets rates of 30 to 50 million per hour. I don't even pay attention to it because, believe it or not, it takes about 3 minutes to restore. That's it. It actually takes longer to capture the critical files at the very end than it does to actually capture the data. So anyway, all right, one more slide on this, I think. Where is it? There it is. Okay. So yeah, I'm remind myself that I'm doing this. Zeroing the profilers, that's what allows me, after it sleep for 60 seconds, to gather new data to give me the read-write numbers. Plus, I've got DB spaces restored, 1 out of 185. Last logical log restored. I'm at that one, trying to go to that one. I think that math is actually right. There was a bug in this for a while, and I think I fixed it. So at any time, if somebody says, well, is the restore done? I can say, well, no, it's got a long way to go. I can tell that by this. But I can also see that if I'm at 170, it's wrapping up, and I've only got a few logical logs to, I take that back. If I'm at 170 Not until I've got everything except for the temp DB spaces, for example, will it start applying these logical logs. The logical logs get applied pretty quickly, but they're not instantaneous, as you might know. And then at the bottom, I sleep for 60 seconds and I go back and do it again. So yeah, this I think is a really handy script, and I'm welcome to give it. I'm happy to give it to you. As Barry will tell you, if I give you anything, you have to make sure it works. So you'll have to clean it up because she's had to clean up some of my stuff before. So anyway, it's the focus of a 2-year-old problem. But anyway, any comments on that? I think it's a really handy thing. Thanks so much, Doug. That Linux Watch thing is just too exciting, man. I'll tell you that could be really, really handy. All right, let me, I've got a checklist here that I'm going through. All right, I know it's already 10 after, but I'm going to continue moving. Let me see what I want to do. I want to do the where is a row ID. Yeah, let's do that. This was fun to put together. The row ID, we remember, points to the data row via a logical page and a slot number. Many people think it's with the data row. It's not. When I tell people that, they just don't believe me because they read somewhere that there's an additional 4 bytes with the data row. Yeah, that's right. That's the slot table entry. So when you're calculating overhead for the data, do include an additional 4 bytes, but it's not for the row ID, it's for the slot table entry. And this proof is not as long-winded as it is implying there, but let me show you. All right, just a reminder, 3 bytes, 1 byte. Okay, we did that. We beat that to death pretty well. So if the row ID is not with the row, why can I do this? I got them both here. I said select row ID and hex of row ID for obvious reasons. A lot of you will just get the row ID. The site that I'm at still has a ton of row ID applications driven by row IDs here, there, and yonder. Anyway, not recommended for those of you newer to our world. Yeah, don't be doing row ID logic for numerous reasons. It's a whole nother conversation, but be careful with that. So I can say row ID here, the hex of row ID, and then there's the first 3 rows from the state table. You guys recognize this. This is the DB Access demo database, so I call it Skippy. So yeah, where's this row ID coming from? So people still think it's coming from the front of the row. It's kind of coming from the front of the row, but not really. So let me show you. Imagine in Skippy, I've got a state table. There are 2 columns, code and S name. You all have seen this. It is 17 bytes total. I built 1 index on that code column. So the index, and again, would you ever build an index on 50 rows in a state table? Probably not, but play along. So I've got an index on the code column. That's that. So that's the setup. Remember 17 bytes. That's going to be important in the next few slides. All right, let's do a PT, a P lowercase t, technically it's called a table space report. Let's look at the state table and just look at that first data fragment, okay? It's the first data fragment because it's the first fragment that comes out in the PT. The next one would say index fragment, etc. Just play along. Maximum row size is 17. Another way I can tell that it's, so I snapped this when I had truncated it. So play along, it's okay. I reloaded it later. So I was going to say another way I can tell is because it has 0 rows. No, it should have 50 rows there or whatever. But maximum row size, 17. Let's get the physical page, which is chunk 1, page 355187. I'll show you the on check we're going to use here in just a minute. I know this is also not an index fragment. I had to think about it for a second because the number of keys says 0, okay? In an index fragment, the number of rows will always say 0. The number of keys will say 1, for example. But this is when I was playing with the truncate table proof, which we may or may not get to today. And I forgot to reload it. So that's that. All right. A quick reminder or a quick lesson on OnCheck. OnCheck has many options. 2 ways to dump the pages are shown below. I get them confused all the time. They're pretty syntax heavy, pretty verbose, but you're essentially in this part of the presentation, we're going to use the uppercase P, that's actually an uppercase P, dump page for a given table and row ID, fragment and row ID, table space, page number, etc., etc. Bye, Mary. And glad you could hear us. We're glad we could hear you. I'm going to go see Gino in June, by the way.
Awesome.
Yeah, I'll let you know about it. Anyway, this is that's the lowercase p. This is the uppercase P. I'm doing it backwards. Mary got me all distracted. Dump the page for a given chunk number and page number. Okay, so there's two ways to do it. Believe it or not, there are times when one option outruns the other. In other words, if you have the same information, the same arguments that are appropriate, you don't see the same thing, which is kind of odd, but that's the way it goes. We're going to look at the first data page by onCheck P big P. That is chunk number 1. I should have spread this out a little bit. Chunk number 1, page offset that. Remember where we got that from. If you ever want to see what the extents are by physical page, ignore logical page in this example. Physical page, chunk 1, colon, that. It used to be a different format. It's much easier to read now. It has been for a long time. So we're going to do the onCheck P uppercase P. Okay, where is it? There it is. All right. I'm missing some stuff. Okay. I thought I was going after the first data page because it was page 1. I wonder why. This is a free page. This is the same look and feel of this page. It's called a free page. One part of the presentation we haven't done is looking at the chunks. All right, I'm going to do that. Okay, what just happened? I just lost you. Hold on. Let me do something real quick. I want to grab a slide if I can find it. Second. That's not the one. My apologies. I'm trying to find the slide that talks about the chunk, the bitmap page, and that type of thing. All right. I don't want to waste more time. Let's go back to where I was. I'll just try to explain it. Okay. Let me catch up. Okay, I thought I was going after the first data page because this is the snapshot of that first data fragment, physical page or chunk 1, physical page, whatever. When I get there, I notice that it says it's a free page. It's not a data page. Each partition, this will work, each partition will have at least one bitmap page. Each table space, each index fragment will have at least one bitmap page. A bitmap page is pretty simple. It is a string of numbers, 1 per page, that tells is a page available for use. This is what a bitmap page looks like in a better format. These two onChecks happen to be showing the same page. Look at the address. This is one of the anomalies of onCheck, is that the only way to see the content of the bitmap page is use P upper P. P lower P doesn't show you much of anything. So I kind of stumbled into that on purpose to show you a bitmap page. I've got to go one page, at least one page past to get to the data page. The type is free. Why it doesn't say bitmap, who knows? The flag is 4. The flag for the bitmap page is always a 4. Okay? As I just said, one flavor is different than the other. Okay. I was trying to remember what that green box was. This 8 right here is the flag for the page we're on. The flag for a bitmap page happens to be an 8. For whatever reason, it's an 8. So if I saw a bunch of 8s sprinkled through here, which is absolutely possible, if you have a very, very large table, you can have hundreds, if not thousands, of bitmap pages, okay? But in this case, this is the flag for itself. This is the flag for the first data page. 4 means partially full. C means full. There's no C on there. I just threw it in there to add some more detail. Keep one thing in mind with our product and probably any of the other products out there. When we say a page is full, it could be full to the gills. There could be no free space rule whatsoever. Chances are that's not true. Chances are it's full, but it can't accommodate a full-size row. Again, we always want to strive towards putting full-size rows. Sorry, we always want to strive to not split a row. So instead of splitting a row and eating up the last 3 bytes of a page, which would be impossible because we need 4 bytes for the forward pointer, if we had a page that had 7 bytes free, we could put 3 bytes from the row on the page and a forward pointer. And then we'd have to have another 4 bytes for the slot table. Okay, I'm winding myself into a dilemma here. We will definitely not split rows if we can help it. That's the best way to summarize that mess. All right, so let's move on to... Okay, sorry, I was going backwards. My cat jumped up on the table, so that's my excuse. All right, on check P upper P, followed by a 1, followed by 355,188. Remember, 187 was the bitmap page, right? That's that one. That's the bitmap page. So we have to go to at least one more page. Is it possible the next page is a bitmap page? Nah, probably not, because when we allocate this chunk, we're going to give it a bitmap page first, then start filling out data pages, and then eventually a bitmap page can be put together. The client I was talking about earlier that came to a grinding halt because they had a DB space that was very, very tall and not wide at all. One of the talks I'd like to do someday is how did I troubleshoot that? I knew they had contention, but I had to prove what it was. As it turned out, I used onstat minus big X to figure out that they weren't waiting on blob pages, they were waiting on bitmap pages. There were thousands of users waiting on a chance to get to a bitmap page. And I could only tell that by the big X and the type of page that they were waiting on. So there's a case where there were so many blobs that they had hundreds, if not thousands, of bitmap pages, and all their users are lining up trying to get to a bitmap page to find a free page. So bitmap pages are very important and are at the front of each chunk and most often sprinkled throughout the chunk. Okay, this topic, sorry, I tangented again. This topic is where is the physical row ID? I'm looking at the first data page. Notice it's a length of 17. That kind of answers the question. If the 4-byte row ID was embedded within the row, you would think the length would be 21, but it's 17. Notice this is 1 past the bitmap. It's the first data page. What do you notice here? You've got the first column, which was AK, which was the code, that 2-byte column. We haven't talked about indexes here at all. We're heading that way, but we're not talking about indexes at all. And by the way, I cut a bunch of slots out here, big deal. AK is the code, Alaska is the state. AK, A-L-A-S-K, that's Alaska. 20 are blanks, okay? So that shows that this is the row. There is no row ID in sight, so it's not embedded with the data row. Okay, now, I don't know where my on check went. I went ahead and did an on check on the index page. I apologize that I don't have that one. You can see what it is. The way I figured out that address is I did an on check PT, went to the index fragment output, grabbed the part num from there, or looked at the index fragment, grabbed the first extent from there. Same rule is true. If I went to page 355114, I'd be looking at the bitmap page. In this case, I went to 5115. That's the first B tree page. I know that because I know that. Notice it's a length of 7. Okay. How big was our index row? It was 2 bytes. So why is this a length of 7? Because the code, for example, is AK. Slot 1, okay. That's the A, that's the K. I just picked another one out here. I don't know why I'm highlighting that. Why am I highlighting that one? Oh, I know. Okay, so let's back up. Slot 1 is AK. I put this in. This is not part of the output. I got this off the web. 4.1 is A, 4B is K. Lowercase, you notice. That's one thing about our product if you're new to it. There's a number of places in on stats where we will uppercase hex or lowercase hex. And here's an output where we're lowercasing hex, and other things might have it uppercase. It'll drive you crazy. It's just one of those things where you many times have to use a TR function to change to lower to upper to make sure the match. If you're using a grep, if you're doing a little more thinking in your searching, then you can figure it out. But yeah, uppercase, lowercase hex stuff is going to drive you crazy if you're really ingesting and digesting on stats. Okay, what I did is I just picked this row here just to show you where the row ID is and how we confirm that it's pointing to the data row. 4.1 is A, 5.2 is, trust me, it rolled off the screen, 5.2 is R. That's not 41, by the way. That's 4/16 plus 1 because it's in hex, all right? That's important for this next piece right here. 1, 2, 3, 4, 5, okay? Notice 1, 2, 3, 4, 5, 6, 7. That's the length of that row. That's why it's 7 bytes. The first 2 bytes are AR. The next 1, 2, 3, 4 bytes is the, anyone? Bueller? Anyone? Somebody say row ID. That's the row ID. The row ID is embedded in the index row. That makes sense because it's pointing to where the data row lives. Does anybody know this is the test to see who all is still with me? What's this single byte here? What's that for? Anyone? Anyone? All right, you guys are all, thank you, Paul. I said you guys are all multitasking. That's the delete flag. So if I look at this, 0, 0, 1, 17, no, that's 1, 7. In on-check output, insignificant or leading zeros are not shown. So this string right here is actually 0, 0, 0, 0, 0, 1, 17. Remember the row ID format. The first 3 bytes is the logical page, not the physical page, the logical page in the table space. And the 1, 7 is the slot table entry. This is in hex, which is base 16. If we convert it, it's 0, 1, 2, 3 in decimal. So we want to go to logical page 1, slot 23. Guess what slide comes next? Logical page 1, right here. I started to point here. Logical page 1 of the data page, slot 23. Notice that's the data row. That is equivalent to everything there up to the first 2, 0. Anyway, a long-winded proof that I've always wanted to do. I did this one just this week because people still tend to argue with me about, well, we're calculating overhead. Where are the 4 bytes? Where's the row ID? Let's go back. So why can I do that? Why can I do select row ID, hex row ID, whatever, and code from state and get something back? This is why people think that I'm lying when I say it's not with the row ID or not with the row. This output is derived. It's derived from the page, okay? Now, I'm not talking about adding row IDs to fragmented tables, et cetera, et cetera. There's all kinds of other things about that with row ID. I'm not talking about that. This is just a normal old-fashioned boring table and index where the row ID is part of the index and not part of the data page. Any questions on that? All right. If I was in the classroom, I'd be giving you a break. I think I'll just push through to see if we can get through some other things. And we're obviously not going to get through everything, but that's expected. I'm not worried about that. All right, let's do this. Let's do a quickie. Thank you, Ashok. Good. Thanks for jumping in. All right, let's see. Got that. All right, let's see.
Hey, Mark.
Yeah, go ahead.
Sorry, my mic was muted even though I hit unmute. So if that was fine for index, but if the data page isn't indexed, where's the row ID stored?
It isn't.
Oh, okay.
No, it's just derived. Yeah, and that's usually the run-on question, Mike, that somebody says, well, where is it? If it's no, it doesn't matter. It's just derived. Does that make sense? In other words, it's not stored physically anywhere.
Right, right. You just figure out the slot ID and then pop it and then just roll it backwards. Got it. Okay.
Yeah. When we read that data page, we just derive it and give it to you if you ask for it. Yeah. Good question. That's, like I say, that's usually the one people ask after I explain all that. And even after that, most people don't believe me, and that's okay. I don't care. I get paid the same. So, all right. Trying to think. I want to work in a quickie here. Oh, let's do this real quick one. This is a one pager. Sometimes people, yeah, we probably will have to do a session continuation for sure. Sometimes people ask, can I get fragment elimination without using PDQ? And my first question is, why wouldn't you want to use PDQ? And they say, because we have work group. I said, well, that's a good reason to not use PDQ since it doesn't work. You still can get elimination based on a number of things. I don't mean that to sound complicated. It's based on a number of things, but what I did is a real simple workup here. I loaded a table called the watcher table with two different categories, box CPU idle and another box. I think I don't have another slide on this, but there are two different categories is my point. I do select count from the watcher table where category is box CPU idle. It's in two different DB spaces. And again, I wished I had more slides on this, but I don't. Notice we read parallel fragment 0. That doesn't mean we didn't read any. Here's something to write down if you're doing PDQ and trying to analyze things like fragment elimination. In this output, the fragment numbering starts at 0. Does it make sense? I don't know. It starts at 0. So in this example, we had a fragmented table, did not use PDQ, and we still got fragment elimination. So that's an easy one. It's quick, it's dirty, but it's important because there are certain limitations with workgroup, for example, that you can't use. You can't use PDQ anyway, but you can still get elimination. Now, this is an equality. You can't get eliminations on range scans and a number of other things. If you need help with that type of thing, let me know. It's one of my favorite topics. Is playing with PDQ and really utilizing memory and allocation to do it right. Okay.
I'm going to jump back really quick in time with you, Mark.
Yeah, go ahead.
We originally met when fragmentation was first being discussed and how you had to fragment across DB spaces. And I said, well, why don't you fragment within a DB space? And you're like, why would you do that? And I was like, because that way you get fragment elimination.
Yeah.
And you can fragment within DB spaces. So even if you are out there just using one DB space for everything, you can do fragment elimination inside the same DB space.
So when we first started with fragmentation, we didn't have that feature, but it came in a long time ago. Where what Mike is saying is you can use the partition keyword and fragment within a single DB space, and you can get elimination and parallelism. Okay. Yeah, that's why I said, Paul. That's why I said use the word partition.
So I only just come back.
Yeah, thank you. Oh, I got to go back to where I was. I got to start over now.
No. I can cope.
Now, what Paul's saying is that it's funny because why didn't we call it partitioning? Believe it or not, I heard when I was at Informix that we couldn't call it partitioning because Oracle called it that. Who knows? So we called it fragmentation, and it always has a bad context with it when it's actually one of our most important, powerful features. What Mike is talking about is having multiple fragments in a single DB space. Multiple fragments in a single DB space. What Paul is commenting on is you actually use the keyword partition to name the partitions within that DB space. Rhonda and Bruce, there's another topic that we have to cover here. I'm going to ask for money for these anyway. Range partitioning and interval partitioning is really cool. Okay, it's really, really cool. Paul, I bet you've done some stuff with that. I mean, it's awesome. So
rolling windows is the most useful one, in my world anyway.
Oh, I agree. And I haven't played with rolling windows. I understand what it will do. I haven't played with it, so I may have to bug you. And you know what we should do? We should team up and see who wins. But anyway.
I admit defeat.
Yeah, I'm sure. Only because I talk more than you do. But anyway, Mike is right. And that's one of those other operations. Remember early on, I said something about in a lot of cases, you get a single scan thread per DB space. In that case, that's not true. And that's really, really important if you're doing partitioning, as Paul said, or fragmentation. So, all right, let me go and let me see. What do I want to do? Oh, I've got 2 more topics to do. They're short. Let me do this one first. I don't know that these are vNext features because I was able to proof them. So I think I got confused in my vNext output printout and my cool features in 14 printout. So play along, we'll cover them anyway. So I apologize, don't write these down as vNext features. This is available now because I was able to do it. So it's not a vNext, it's a 14 whatever. I'm using 14 FC7, so sorry. Truncate table keeps statistics. I use truncate table quite often. Those of you that are new to the environment, don't forget about truncate table. Most products have it. Oracle's had it for a long time. We've had it for quite a while. It essentially lets you wipe the contents of the table without dropping the table. It helps you avoid really, really long running deletes, etc. Blah, 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 blah. Long running deletes will take locks. You can run out of locks. You know the story. So anyway. Yeah, you guys, how many out there, I wonder, have ever, back in the day, doing a mass delete or a mass insert, and you're watching the row count go up, and then all of a sudden it starts going backwards? And what happened? Well, obviously you're getting rolled back. That's in the next little section I'll do. But anyway, be careful with that. This is for large tables that might get repopulated soon. The keep statistics option helps the optimizer avoid costly sequential scans. Real quick, 3 or 4 slides, that's it. I create the Skippy DB Access demo database. I get the distributions on state. What? Okay. Well, that's weird. I've got some mixing and matching here. I do an update stats high, then I do this, and what's it tell me? It shows me the distributions. That's the whole point of that. Yeah, I've got some stuff tangled here. Then I do a truncate table state, table truncated, etc. I do the DB schema minus HD. One of the weirdest formats. I mean, weirdest usage. But anyway, HD, and I got nothing back. So I put in no statistics to be found. That doesn't come back as the function of the DB schema. I put that in, which is what we expected. And this one gets a little more convoluted. I apologize. I should have broken this one up, but I went ahead and reloaded the table, the state table. Remember in an earlier slide when I said I hadn't reloaded it, and this is where I reloaded it. Update statistics high, statistics updated, whatever. I do the DB schema HD. There's the stats. I do a truncate table state, keep statistics, blah, blah, blah. Okay, I look and there are the statistics. Okay, and more statistics. But then I look at how many rows are in the table. I apologize. There it is. And the table has 0 rows. That's all there is to it. Okay, it's that easy. And the table stays out there. Notice that the page allocations are still there. The index pages are still there, whatever it might be. Okay, so I think this will be handy in certain situations. I think it's a pretty cool feature. So.
Mark, isn't there a truncate table keep storage as well, or something like that?
It does, yeah. In both cases, it keeps the storage out there. That's what I was showing
you. You can drop the statistics, but keep the storage.
Absolutely.
Yeah.
What Paul's talking about is when I did this truncate table state, I meant to show the pages that were left over, and I forgot. When I did truncate table keep stats, if I didn't have keep statistics here, that stuff would still be there. You'd still have 8 pages. You're absolutely right. And there's a benefit to that. I think Paul's probably alluding to, if it's a large table, lots of disk out there, etc., you go ahead and it's already allocated. Yeah, we're going to get into a PT extend conversation maybe next time around that talks about how you can run into a long transaction due to extent allocations. But that's a whole nother topic. All right, let me press through this real quick, just a second. All right. We will start wrapping up here in just a minute. I'm definitely not going to get through everything, but that's okay. I'd love to go through logging, but it's definitely a lengthy one. did the watch restore, did that. Let's just wrap up with a couple little bits and pieces then. One nice feature, and again, it's not a vNext, it's a version 14. Moving the physical log. We've had a few iterations of how to move the physical log to its own DB space over releases here and there. This is a nice little feature. Notice I do an onstat minus L. It's in chunk 1, page 263. Onstat minus on spaces minus C minus big P. Give it a name, give it a path, give it a size, give it an offset. This will actually create a brand new DB space for you, assuming all things equal. This is created or available. This is 660 and it's owned by group and owner Informix. So this will actually create you a brand new DB space and move the physical log there. In this case, that's how I know, because it's in chunk 8, page 53. Page 53, 2 pages reserved for future use, 1 page for the chunk free list, and 50 pages for the table space. Table space is 53 pages. Starting at page 0, the first allocation of the physical log will start at page 53, and it's of this size. One thing to remember about the physical log, that physical log must be in contiguous space, okay? If you try to allocate a physical log that's bigger than the available contiguous space, it will fail. You might do an onstat minus D, and I said, I've got 4 gig, but you've got other stuff in there, which is not a good idea, but that's a whole nother topic. But you don't have 2 gig contiguous space, and that's how big you want the physical log. It'll just fail. So you got to have contiguous space for the physical log. All right. Got that. All right, let's just do a few more quickies. If you don't use onstat minus G PTUS, get familiar with it. It is very handy. Came over from XPS many releases ago. I use it often to watch query operations in flight. I use it when I get the call and the user says, I'm certain my query is stuck. I'm certain it's not running. Okay. This is what it looks like. That's all the time I'm going to spend on it. You say onstat minus G, I do a minus GR PQS followed by the session ID. And it's going to give you what's going on as far as the statement type, the ins and outs, the iterators, the time spent, the number of rows, et cetera, et cetera. It does a scan, does a nested loop join, scan, whatever it might be. I tend to watch this in the version I'm using because it doesn't have nearly as much information as we have here. But you can tell how many rows are left. You can tell how many rows are being unloaded or processed. More than anything, you can tell if the thing is moving. Now, in later releases of 14, you can also add, you can throw dynamic explain at a running query in a much different way than we first introduced it, if I remember right. Sometimes that doesn't work as well as we think. This is pretty handy, and I use it quite often. All right, we did that. All right, let's do this one, and maybe we'll call it quits. One thing that I've had to deal with is really big B trees, especially the nightmare of having a very hot, large duplicate index. Okay. I've had to prove that B tree maintenance was a big performance hit. We always try to balance the B tree. B doesn't stand for binary, it stands for balanced. Can be tuned a lot with the B tree scanner settings. Way back in the day, we couldn't, but now we can. That's been around for a long time. This is especially useful with the horror of a very large hot duplicate index. Let me read this to you and then I'll explain it. A duplicate index that is large and has lots of duplicate values will have a long list of row IDs within the index of the B tree itself. So believe it or not, the way we manage duplicate indexes is it's almost like having an index within an index. The hard part is that list of row IDs has to be in order. The index itself is ordered, okay? And the row IDs that are in the duplicate or in the list, the row IDs for the multiple data rows, that are in the B tree have to be in order as well. Okay. I remember arriving at a site and their month-end processes were taking absolutely forever. And I looked at it and I said, you got a lot of duplicate indexes, whatever. I looked at what the duplicity was. I looked at how big the indexes were, etc. I just introduced one more column to the index to give it a little more uniqueness. It wasn't unique, period. It gave it a little more uniqueness and a lot less high level of duplicity, if that's the right word. It was tremendous, the difference in the month-end processing, because we were spending so much time doing maintenance, balancing the B tree, trying to reorder the row ID list, shuffle, split, merge, whatever it might be. Okay. You can look at the logical logs for lots of operations. I've always said if we could write a logical log parser that didn't have any impact, it would be amazing. Okay, it'd absolutely be amazing the stuff you could learn. This example snoops for heavy B tree operations. Don't miss this warning. I know it's at the end of the session. Don't fall asleep and miss this warning. OnLog by itself will read all the logs. You don't want to do that. And there was a version of IDS, if anybody knows the answer to this, speak up.
It's on the chat there, Mark.
I see that, yeah. On current log used to be very, okay, not an issue anymore. Okay, Paul just answered my question. That's why I threw it in here. Anyone, Bueller? Back in the day, if I read just a single log, it would log latch all the logs. And I figured we had changed that, Paul. I just didn't remember.
I only remember it being if you worked on the current log, it would lock the, well, it would basically lock the engine.
Exactly. Well, and I was always told it took a log latch over all the logs, which pretty much stops everything. So yeah. So that's good to know. I appreciate that. So here's an example. There goes the example. This example right here, I keep wanting to highlight stuff with my cursor, but anyway. I picked a log from a relatively busy engine, onlog -n, followed by the log number. I'm egrepping for add item, BT merge, BT shuffle, spelled the right way, and BT split. I print out column 3, I sorted, I do uniques -3, and I sort -nr. I think there's a way to combine those, but anyway. So I ended up with, what is that? 2.2 million add items, 2.2 million row inserts to the index, 9601 BT splits, 545 BT merges. The bottom numbers are made up. I couldn't find a log real quick to have a lot of stuff, but let me explain what that would have mean if they were real. The top one's real, but the bottom two are not. A BT merge. If you consider an index, there's multiple pages and multiple levels in an index. If a couple of pages or more become relatively free, and that makes no sense whatsoever, don't have a lot of entries on it, to the point where it's really wasting space on those pages, we can merge those two pages together. So we would merge those two pages into one. That's what BT merge means. BT is short for B tree. That's good. But if you merge those two pages together, there's a bunch of pointers that have to be adjusted, a bunch of things on the other pages and other levels, all the way back to the root node that has to be adjusted. And so that can be quite an impacting thing. BT split literally means, keep in mind, index rows on pages are in order. 1 through whatever on this page, whatever plus 1 through whatever plus Z on this page, etc. If I have a new value coming in, if somebody inserts a new data row with a new index value, and that value has to go on one of those index pages in order, and there's no room, okay? I can't just throw it out there and say, by the way, don't forget me over here. It's got to go in its spot where it's in sequential order, in order on that page. So in that case, we have to split the page. We split the page and move relatively half to one page and relatively half to the other. Splitting the page is okay, but then we have to also change the other levels contents. And again, this is a whole nother discussion, long discussion. But that's a split. A shuffle literally means we're shuffling, which I don't have an example on the bottom here, the shuffle, but it's right here in the egrep. The shuffle means we're shuffling values amongst the nodes to help more relatively balance the tree. So with all that said, you can do an on log and look and just prove that you've got lots and lots of maintenance out there. Now, with the BT scanners, that's actually what they're called, B-tree scanners in the documentation. There's a lot of ways to see who's busy, who's not, who's hot, who's not. I like this just because it's fun doing the low-level dive into the logical logs. But I'm certain that the B-tree scanner options and outputs of the OnStat minus G BTR, that's a guess, will give you who's hot, who's not, etc. And you can tune the cleanup algorithms based on a couple different approaches. So keep this in mind, but also don't forget the B-tree scanner on stats that you can look at and really benefit from. All right.
Mark, that's kind of interesting because before you had said that on a lot of clients, you're moving indexes onto very large pages, 16K
Yeah.
buffers and 16K pages. And my first thought was, well, when you have to rebuild the index, you're locking a whole lot of rows at that point as it's rebuilding, as it's changing pieces in that index.
Agreed. Now, they're going to do row level locking on those. Okay. Now, as far as shuffling, merging, and splitting, that would be at a page level, which we don't control.
Right.
I
Yeah.
understand what you're saying. That's a good point, Mike.
Okay.
You
Because we run into issues. We're using BTS, the basic test search, and we run into issues all the time when it has to redo its internal index, and we have no control over that. But it locks the whole BTS search out, and we have to wait till it finishes redoing the indexes.
Huh. And I know zero about the text search blade. That's what you use.
Nobody knows anything about the text search blades. I have learned.
Thank you, Paul. Yeah, OnStat Big C is what I meant for the B-tree scanners. Yeah, that's when I said BTS, I'm thinking, no, that doesn't sound right. That sounds like a boy band from Japan. But anyway, OnStat Big C, yeah. But yeah, Mike, that's I think you're see, you could become an expert. You should write a book on the text search blade, and you could become famous. Anyway.
Yeah, okay. There's a lot of therapy involved in that.
All right. We should probably wrap it up. The one I didn't get to. Go ahead.
I was going to say we probably need to, Mark, and go ahead and schedule another session or two.
Yeah. Oh, by the way, in the chat, Paul threw his OnStat Bible link in there. He's got a lot of stuff out there with OnStats. Feel free to jump in. He's spent a lot of time. I know where he got the source, but he spent a lot of time making that very usable. And
yeah, originally it was an internal IBM doc.
I know.
Troy somebody, I think.
Troy Hewitt.
Yeah.
Yep. I carried it around forever. When I saw it, I said, I know where Paul got that. But with us, we don't care. We just want to get the information out there.
One of the funniest ones on the IBM website, I can't remember which one it is, but they've screen scraped part of my OnStat into their official documents. It's quite funny because I recognize the username and the system.
Well, when I left, there was actually a few presentations that I sat in of Carlton's, and they actually said, courtesy of Mark Scranton. I said, you got to be kidding me.
There's irony.
I thought that, no, the thing with Troy Hewitt, I never met the guy. He was a consultant, and I'm thinking, who in the world had enough time to put that much detail into an OnStat doc? It was great. It was awesome. But can you imagine how long that would take, Paul? I mean, you transcribe.
Yeah, a long time. And just as a general comment, if anybody on the call, if you find something in an OnStat that doesn't make sense, raise a PMR. They are more than happy to explain what those columns mean to you.
Yeah, definitely. And it seems like the documentation on the HCL site has gotten better, but I still think that you've got a lot of good details and paragraphs on yours. So I'm finding it easier to find OnStat information than I used to. Maybe I'm just dreaming. I don't know, but it's very handy. So yeah, we probably should wrap this up. I didn't get to a couple that I wanted to, but we'll just schedule another one because it's done, so to speak. But does anybody have any questions or concerns? Any questions about anything? Let me put my email in the bottom of the chat. I took my website down years ago because I didn't want to have a million clients like Paul does. So one of these days I'll resurrect it. To be honest, I just want to teach again, so I'm envious what Lester does. He retired and still teaches, so good for him. But I'm still waiting on Mr. Walker to say, would you teach a class for us? But you would probably teach it, Mike. So anyway. All right. If there are no questions, thanks again for hanging in there. And
thank you, Mark, for doing this for us. We will get this posted hopefully the next day or so.
Okay.
And everybody, if they just keep watching the IG website, we will post the next one and when it'll be.
Okay. Thanks,
Fantastic.
everybody.
Thanks, Mark.
Thank you, guys.
Cheers, Mark.
Good to talk to you.
Bye.
Thanks for the help. I appreciate it.
Thanks.